Reactions and explanations for first group. So, the first point is, out of three insoluble chlorides, that is Hg2Cl2, AgCl and PbCl2, the last one is soluble in hot water, hence the filtrate will consist of PbCl2 only. This can be divided into three parts as we have recently discussed, and the presence of lead ions is confirmed by Pb2 plus I minus, that is from potassium iodide. We get Pbi2, a yellow precipitate, which is soluble in excess of Ki, forming a complex Pbi4 with two negative charge. But if we add potassium chromate, then lead ions and chromate ions combine to give lead chromate PbCrO4, a yellow precipitate. This yellow precipitate is soluble in nitric acid or in sodium hydroxide. The yellow precipitate of lead chromate, on dissolving into nitric acid, splits up or dissociates into two lead ions plus dichromate ions plus water. In fact, these lead ions are present in the solution as lead nitrate. But we cannot use hydrochloric acid or sulfuric acid in place of nitric acid here. Otherwise, PbCl2 or PbSO4 will be precipitated. We have noted that lead chromate yellow precipitate is also soluble in sodium hydroxide. Let us see what happens when it is dissolved in sodium hydroxide. So here PbCrO4 plus 4OH minus, these ions come from sodium hydroxide. The reaction is reversible and we get a soluble complex, that is PbOH4 with two negative charge plus chromate ions. Remember, dichromate ions exist in acid medium but converted into chromate ions in alkaline medium. Thus it is a pH based equilibrium and not a redox reaction. That is H2O plus Cr2O7 2 minus changing into 2 CrO4 2 minus plus 2H ions. Thus, if H plus ion concentration is more, then the above equilibrium goes backward, and if H plus ion concentration is decreased by adding OH ions, the equilibrium goes in forward direction. Lead ions also combine with sulfate ions from dilute sulfuric acid to give PbSO4, a white precipitate. PbSO4 is soluble in concentrated solution of ammonium acetate in presence of ammonium hydroxide, forming a soluble complex anion, that is tetraacetato-plumbate second, Pb CH3COO4 with two negative charge. The residue may contain Hg2Cl2 and AgCl, but this residue is dissolved in ammonium hydroxide. Only AgCl, if present, will be dissolved. According to the reaction, AgCl plus 2NH3 aqueous, we get AgNH3(2Cl). This is a soluble complex giving a colorless solution. This solution can be divided into two parts, and presence of silver ions is confirmed by. So, either add iodide ion to the solution containing silver ions. These iodide ions will come from potassium iodide. Then silver iodide's yellow precipitate is formed. It is not soluble even in concentrated NH3 aqueous. The second reaction is silver ions plus chromate ions. These chromate ions come from potassium chromate. So we get silver chromate AgCrO4 that forms a brick red colored precipitate. Finally, the residue remaining may contain Hg plus HgNH2Cl due to the following reactions, or the reaction is Hg2Cl2 plus 2NH4OH forming HgNH2Cl, that's a white precipitate, plus mercury, that is in the form of finely divided mercury. These finely divided particles of mercury are black in color. As a result of that, the combined color of these two becomes black, plus NH4Cl plus 2H2O. This is a disproportionation reaction, and very important to distinguish mercurous chloride from silver chloride and lead chloride, as these are soluble in aqueous ammonia. When this black residue is dissolved in aqua regia, that is 3HCl plus HNO3, it gets dissolved, converting all the mercury into soluble mercury chloride. From this solution, presence of mercuric ions, note that now there are no mercurous ions, can be shown by the following reaction. 2Hg2 plus Sn2 plus, we get mercurous ion plus Sn4 plus. Next, mercurous ion plus Sn2 plus, but now they are in the excess of amount. By adding excess of SnCl2, we get finely divided mercury in the form of black particles plus Sn4 plus. So we can write Hg2 plus plus 2I minus from Ki to give Hgi2, that is the red PPT. Add more of Ki to it in excess of amount. We get a colorless solution, that is K2HgI4.